we have our guest today on the show. He's an undergraduate and a student of University of Lagos. So a big shout out to you all. So tell us, what do you have for us today? What's your innovation about?
All right. So it's for farmers basically. I mean, I feel like agriculture is one of the big drivers of every country's economy, right? And if there's a way we can infuse technology to make agriculture better, I think I'm all for that, right?
Absolutely. So we can have more food.
Definitely.
Right.
Yeah.
And of course, the food can even be cheaper because right now almost everything is on the rise.
Everything is on the rise, yeah.
So I think, yes, like you said, we need tech to help us
exactly.
there.
So basically, it's a machine learning app such that farmers can get to know what's happening in the farm in real time. Now, knowing is not enough. They also have to know the next line of action. So it's a machine learning app that uses factors like temperature, humidity, light intensity, soil moisture, and then uses these features to then predict the status of the farm, of the crops in the farm actually, right?
Okay.
So knowing if...
Slow down. See, our audience are a mix of those that know and those that don't know.
Right.
So what's machine learning?
Oh, wow. I love a question. I think machine learning fundamentally is giving a computer the ability to think the way humans think.
Yeah.
And now you have to think, how do we learn as humans? We learn from example.
That's it.
So I love to give this example. Let's say you have a kid, like an infant, for instance, and you know the lantern we used to have back in the day.
Lantern back in the day with kerosene and all that.
Yeah, right.
Oh, you witnessed that as young as you are? Okay.
I did, yeah.
All right.
So if a child sees that and perhaps the child touches it, obviously the child has that response to the stimuli and perhaps cries and all that. Now, the next time the child sees that thing, doesn't touch it. So that little experience, it's like it's learning from the experience. Now, the child doesn't know it's a lantern. What the child registers is, okay, it's shaped a certain way, it's transparent with a glow coming out of it with the cylindrical.
That's it.
So it learns perhaps the position in the house where it is. So ultimately, the child is learning the properties or the features of that thing because, I mean, I know it's a lantern. The child doesn't know it's a lantern. It's just X and Y thing that is in this place of the house.
That's right.
Right, yeah. So that's basically how humans learn. In the same sense, that's how computers are made to learn.
All right.
So at the core of this machine learning app, it has been trained with data sets of, okay, for instance, we have X and we have this farmland. Okay. This is the humidity, this is the temperature. Based on these features, we've seen that this plant is struggling. Yeah. So having a number, perhaps thousands of that. Yeah. So the computer has been trained on that. Now, based on what it has seen, and I'm giving it new features and telling it to predict what the things happening with this new person's farm. Absolutely. So it's similar to the way we learn as humans, just you've trained the computer to, it has seen these examples. True. And then now do this. It's also similar to how we learn, I think, in primary school, secondary school, they taught us maths. So the teacher comes to class that day and it tells you, it gives an example. It does, perhaps, let's use quadratic equation as an instance here. Yeah. So it solves this, perhaps 3 examples, and then it gives you a classwork. So similarly, it's literally just learning from example. Absolutely, right. But you know, just as an aside, some of those classworks or homeworks that they give us, and you're not asking, like, this is a bit, the teacher did not teach us, you know, to this extent, and sometimes you're not able to solve it. Right, yeah. And so in this case also, so data to machine learning, right, yeah, or, you know, to the tech system or tech app. So data is the humidity. Yeah, exactly. The temperature. Exactly. What else? And the humidity, temperature, soil moisture, just basic factors you think could affect the state of the plants. Okay, because it's very important. Temperature to what's it called? A vegetation area is very, very soil moisture. Important. You can't have a dry land, for instance. Right. You can have. The humidity has to be perfect. Yeah. It can't be too humid and it can't be on the low side too. So it has to be that perfect humidity in the area, right? So just tell me, thank you so much. So tell me, what gathers the data? Because I hear it's an app, right? So what then gathers the data? Because I'm sure that there's no farmer that has. Yeah. So what's the source of the data? All right. So in the machine learning space, there are a couple of historical data that exist already. So this data set has been collected. So what we did basically, myself and my team is that worked on the project together. Okay. So ultimately, we just sourced for these data sets. They are quite available online. So we have platforms like Cargo, platforms like Organ Face. They are readily available. Yeah, and it's free. I get that. So when we got those data sets and then using that data set, we then trained. I think the data set we got was specifically for cassava, for a cassava vegetation, and then we trained our model on that, and that was what we worked with.
Okay, so for now is for cassava and any other plant or crop that is similar to cassava.
Exactly.
So do you plan to like expand it to other kinds of vegetations and farmland?
Definitely, yeah. I mean, what we have now is limited. So every time we have the opportunity to broaden our horizon, I think we're definitely looking forward to that. Even if it means adding more features, perhaps having more sensors in the farm, perhaps a soil pH sensor. Soil pH sensor, just
so that will also help with the soil apart from just the environment.
Definitely, yeah. So we're really looking forward to improving what exists already. I think we can't rest on our horse now that we have something working. If we can improve it, we're definitely looking forward to do that.
Absolutely. And so back to the question that I asked, you've answered one side of it. So what helps to gather the real-time data from the farmland?
All right. So I think of the solution of our innovation as a two-part solution. There's a software part and there's an hardware part. So the hardware part is what we had a simple prototype that works. So just having a little on the breadboard prototype, seeing a couple of sensors. We had a temperature sensor, and humidity sensor. We had a light intensity sensor. And finally, we're looking to add a soil moisture sensor. Just having all these sensors integrated with a microcontroller, an Arduino Uno microcontroller. Then we wrote the code in C++, and then we could actually just in real time see using an LCD as actuators. So I've talked about the sensors. So the actuator in this case is the LCD. And then we get to see the
display screen. If you don't know what LCD is, slow down. Okay, so like a display screen, so that when it gets these what's it called, inputs like humidity and temperature, you get to see it on the screen.
Definitely,
Okay.
So it's just seeing what it has read from the sensor. The actuator then displays it out for us to see. So the farmer then sees that hardware part of the solution. Then the output from the hardware then goes into the software, which is the machine learning application.
You input your data and then it kind of like gives you a figure. So what else does it do? So do I just get to see the figure? So is there some kind of interpretation of the figure that I see?
Exactly. So what you actually see when you use the application is you see the status of your plant. So it tells you perhaps your plant is struggling, perhaps your plant is healthy, perhaps your plant is thriving, perhaps your plant is I reckon there are about 5 different
metrics or something like that.
So basically where your plant is in that metric system, it just tells you where it is. And it just doesn't tell you where it is, it then tells you the next line of action. So I mean your plant is struggling, you might want to do this. You might want to perhaps look at an irrigation system. So just trying to make sure your crops do much better and ultimately we have food.
Perfect. I see this very useful. I mean, just imagine a man has hectares of land and you've actually deployed labor to maybe water it, and you really can't tell how well they have watered, right? Or how well they have applied whatever manure or fertilizer. But by the time we're taking this data, I mean, the man in the US or in Japan is able to see what's happening to either the temperature, to his soil and all of that, instead of coming back and seeing yellow leaves everywhere. So that's quite interesting. So I would like to ask you, what actually informed this your application?
To be honest, it's not very conventional. I think the ideal answer to this would be finding the problem and creating a solution. I think what we had with I think I keep referencing the team, but I don't talk about them that much. So it was a team of 4, myself and 3 other classmates of mine. Right, yeah.
So nice. You guys are busy thinking about Nigeria's problem. While some are so good. So thank you.
Right, yeah. So we all have specific skill sets that majored really in machine learning and IoT. I kept thinking, I mean, we can do this, but then having that knowledge and having pet projects that doesn't really help anyone, I mean, that's not so good. If we can try to work on something that actually has impact, I mean, that would be much better. So that was our thought process. And we kept thinking, I think that's why I referenced how agriculture is such an important industry.
Telling you.
Right, yeah.
Give me food and I'm fine. Even we tech people, we need to eat. Yeah, need to eat, exactly. But you can eat and still do tech. You can eat and be a farmer.
So that was our thought process, just trying to, what can we do? And we're very key on combining IoT and machine learning.
Yeah.
So we understood that IoT, so we had to make sure whatever the IoT was coming up with has to have data, because in the machine learning space, they say data is food.
Yeah.
So you
Yes.
need so you need data to
Yeah.
feed the machine learning model. So we kept thinking, what can we do such that we get a specific data set that we can then inculcate into a machine learning model,
Yeah.
and then we can then help others.
Absolutely. That's very well explained. And also thank you again for breaking it down. So what's the future? What's the future of this application? And what are you here looking for?
For the future,
Yeah.
I think we've talked about the solution a lot, but I think one thing we really want to do is see it work. I think we could think here and be like, okay, let's add the sensor, let's add that sensor. But until we actually get to see it work with an actual farmer, I think there's some feedbacks we can't get yet. So I think the big thing for us now is actually testing it. Yeah, that's the word. Yeah. So getting it tested with an actual farmer, and then tells us, okay, I mean, there are things we can't really see until the farmer like talks about them. Like we can't emphasize those things. So getting that view test and then getting the feedback from that view test, and then we then go back into quote unquote lab and trying to see how we can make the model better. So the future, first of all, is trying to improve it. If it's adding more sensors, getting more data sets, if it's perhaps considering how different the Nigerian agricultural system is, just the uniqueness of the Nigerian agricultural ecosystem, being able to integrate improvements that considers that into our solution. Okay. So basically, we need to test first in the actual world and see how it works, and then we improve on it iteratively. I think that improvement is so important. You know, having that feedback loop. Okay, so we test it, it works good. We come back, improve. You know, have all that. Yeah.
Absolutely. Thank you so much again and again. I've really learned a lot, and thank you for the passion you and your team are putting behind making sure that this app is being rolled out. This is still the Pioneer STEM Show. Keep it locked down. Stay with us and learn.